Dave Chelimsky was the first person to make me actually think about testing beyond just the idea of a test. I remember the first time I ever saw Dave, he had this idea. So when you come to Ruby, you come to Rails, one of the things I liked about Rails, I'll go back a step, I liked about Rails, was to put testing right in the thing. You know, it kind of got in your way. It was a folder. What's this folder for? Eventually you realize I should look in, what is this folder for? It's for tests. What are they? I should write some. And eventually, perhaps you flip it around, you start writing your tests first, and you think, this testing thing is awesome. I write my tests, I write code, and at the end, I get a test. Because writing tests is hard. But Dave had these other thoughts, and Dave showed this wonderful new syntax for how it could be done, or how you could write your test. And it wasn't just about, this is where it gets important, it wasn't just that it was different. Dave understood that the tool itself, which in that case was Aspect, the tool changed your thinking. And that it wasn't that you couldn't have your thoughts changed and go back and use test unit. It was that the tool helped. The tool actually made it easier to do the right thing than perhaps the wrong thing. A tool helped you all the way you're thinking. For example, you might learn Chef, and Chef might teach you about convergence. It doesn't stop you doing convergence in Bash. It's just that Bash never really made it that interesting and easy. Aspect made it, changed his thoughts. He turned it into a tool, and it changed all our thoughts about how testing is. Dave would now like to share a new tool and how it changed his thoughts again. And now we all have to learn with him. Please put your hands together for Dave Chelimsky.
Bon dia, Barcelona. So anyway, there's a lot of new stuff for me, and I was originally, when I was going to do this talk, I was going to show you a bunch of Clojure code, but this is a Ruby conference. You haven't gotten to see too much Ruby, so really what I want to talk about instead is how working in Clojure has impacted the way I want to approach Ruby going forward. So, wow, that just jumped ahead like through the whole thing. All right, so I'm not going to be talking about Clojure. I'm not going to be talking really about functional programming in Ruby. There's plenty of great resources for that. The two that I put up here, one is a talk that talks about how to implement like immutability and something like higher order functions in Ruby, and the other one's a book on a similar topic. But what I am going to talk about is simplicity. In the Clojure community, simplicity is a big deal. And we talk a lot about simplicity in the Ruby community, but by the definitions that we'll talk about in a minute, you'll see it's a little bit different. They've kind of leveled it up a bit. So according to Stu and Aaron, this was one of the two primary things in Rich's inspiration for Clojure. Simplicity and power, these are the two things that drive everything else. And a thing is simple if it's not compound. And Rich likes to use this word complect. And if you've never seen any talks by Rich Hickey and him talking about it, the word complect means to interleave or to braid things together. And this is something that we don't want. And we talk about this all the time. We've got the solid principles that teach us how to keep things small and make it easy to move stuff around. But they take it, I think, to a different level. So the other thing I want to talk about, which is a big topic in the Ruby community, is readability, because we all probably fell in love with Ruby because it's so readable. But readability is a subjective thing. So I'm going to just read what this says for the English speakers. The rest of you can probably figure it out. This is written in Portuguese, and it says that if you're a Portuguese speaker, this is probably legible. If you speak Catalan or Spanish, then it's probably comprehensible. Is that what I said? That's what I said. But for English speakers, not so much, right? So this is perfectly readable for some subset of the audience. It's pretty readable for some other subset, and it's really not readable at all for another subset. So it's very, it's contextual. It depends on your own level of familiarity. We all know what a plus sign does, right? And this is obviously the result we would expect, but what about when we add these two things together? What's Ruby in this context? What's Clojure? What do they add up to? So readability is contextual. And what I want to talk about is how I think we can do better at striving for both of these things at the same time. And I should give you a little bit of context here. Since I've been working on Clojure, I actually left my job a few months ago, and I've just been traveling and taking some time off. So I haven't, except for some contributions to open source projects like RSpec and Rails, I haven't really done the things that I'm going to show you in anger on a full-time project. This is just my personal opinion. You should take it and experiment with it and see what you think. You won't be wrong if you think I'm wrong. But, OK. So let's look at a little bit of code here. Looks kind of confusing. Let's refactor it. So first of all, a little background. This is from RSpec. This is part of the backtrace cleaner. What we try to do is sensibly filter out lines of a backtrace when you get a failure message so that we can filter out some of the noise, like the lines that are in the RSpec code base, for example, aren't really going to help you discover what went wrong with the code that you wrote. There are patterns, regular expressions for exclusions and regular expressions for inclusions. And we're going to figure out, based on what those patterns are, whether to include or exclude a line. So the first thing that's a little confusing here is this, where we assign to the inclusion patterns instance variable. So first we say, hey, if inclusion patterns is nil, and that inclusion patterns at that point is referencing the parameter, right? If that's nil, then let's do all this other stuff and assign the result of that to inclusion patterns instance variable. And if it's not nil, and then in the else clause, then we say, let's go in and assign that not nil thing. So to me, that's backwards, and we should reverse that so that this is a little bit cleaner this way. We say, OK, inclusion patterns or, right? And this is a little more idiomatic Ruby. The next thing I noticed is that we're handling nils coming in two different ways. It's perfectly legit to submit a nil for either argument, or just call this with no arguments at all. But for inclusion patterns, we default to nil, and then handle the nil case inside the initializer. Whereas for the exclusion patterns, we're setting a default in the parameter list. So I'd rather do that the same way. It just makes it a little bit easier to sort of read and figure out what's going on. So now this is super nitpicky, and this has nothing to do with my experience in Clojure, but when you have two arguments like this, you know the code smell of a long argument list, right? Where you have like 4 or 5 arguments or parameters, and you want to wrap them up in an object. But this is just a pair, and they follow each other around everywhere. And it's a little pet peeve of mine when they show up in different order. I want them to always be in the same order, because it's really easy to make typos when they're not. So we can see that they're coming in inclusion and then exclusion, but then they're getting assigned in the other order. So let's reverse that, except some tests failed at this point. I was actually doing this refactoring, by the way, and running the tests between every step. And the problem is that there is a dependency, an ordering dependency. We have to assign a value to exclusion patterns before we can assign a value to inclusion patterns. And it was a little bit hard for me to see, because you can see here, this is matches an exclusion pattern, which refers to this method down here. That's a method, whereas here the syntax highlighter is showing me, oh, here are these things that are related to each other, but I didn't even really see that we were doing anything else with exclusion patterns. So I'm going to inline that, and now it's just much easier to see all the relationships between everything in there. And since I can't switch the order of the assignment, I'm going to do it the other way and switch the order of the parameters. And it turned out that there was only one consumer of this in the code base, and this was a completely harmless change to make. OK, so the next thing is exclude. So does everybody know what the SLAP principle is, the single level of abstraction principle? Does anybody not know what that is? OK, so the idea is that code's a little bit easier to read and understand if everything inside the same method is operating at the same level of abstraction. So you don't have to sort of mentally jump down into the lower parts of the language and then back up to some high-level abstraction. So this violates that. Plus, we've only got one invocation now of this method, so I'm just going to inline the matches and exclusion pattern method. And then the very last little bit is that inside that method, we're handling the exclusions, the inclusions first and then exclusions, so I'm going to turn those around. And now everything's nice and symmetric. We've got less code. It's simple. Simple in the not complected sense. And it's very readable. Well, it's readable, again, this is subjective, right? For me, since I've been dealing a lot with iterators, to me, this is very readable. For people who aren't comfortable with iterators, then it might be less readable. So now there's still a tiny bit of duplication here, and this is actually how we got here. Somebody saw this tiny bit of duplication and said, oh my God, there's this tiny bit of duplication. Better extract a method so that we don't violate the dry principle. 2 years ago, I did a talk about the misunderstanding of the dry principle, essentially. And so for those of you who haven't seen that talk, if you're interested in my opinions about all that, please look it up. It was at the Brazil RubyConf, and there were a couple of others as well. The talk is called Maintaining Balance While Reducing Duplication. So, well, here's a question. If we have an operator with 2 operands, and that happens twice, is that duplication? Are we going to extract an add method? Of course not, right? And in this case, we've got an object, and we're just calling, in the lowercase, we're calling a method on it with an argument. And then we call it, again, with a different argument. Well, we're probably not going to wrap that method in another method in order to reduce the duplication of calling a method twice. That's absurd. So there's definitely a threshold that we can probably all agree on. And then it's just, there's a scale in the middle of where things start to get uncomfortable for you. In this particular case, so in the top lines, exclusion patterns, any. So we've got a collection, we've got an iterator, and we handed a block. And the duplication is that we do this twice with 2 blocks that basically do the same thing. But what value are we going to get out of extracting a method for this? Any exclusion patterns in the methods at the bottom is no more readable than exclusion patterns.any. All that's left really is what's in the block, which could be represented by a match method. And so you can extract out a small method, which in this case has to be a lambda, because we're going to hand it to an iterator. And this is a nice way to do it. It gives us a lot of flexibility. So we can now use that match function with any iterator. We get some reusability out of it. And we're composing small bits to create more complicated things. But still, for me, if you take a look at these 4 possibilities, we could debate about readability, but I'd argue that the first 2 are definitely the simpler of all these, because I don't have to go look at another method somewhere to understand what went wrong somewhere. And I actually prefer the first one, but that's admittedly completely subjective. So in the end, what we have, in my opinion, it's intention revealing even in the blocks. It's symmetric. It honors the slap principle. We use Ruby for the domain of computation. Like, we're using just Ruby, not our own custom methods, for the stuff that's Ruby, like iterate through a collection. And we're not delegating to a method that doesn't really add that much value. So in summary, this far, we want to balance readability and simplicity. Readability is subjective, simplicity is objective. If something is not readable, really, just ask yourself, is it not readable because of my own level of familiarity, or should I maybe understand what this is because I'm trying to improve myself as a Ruby developer? And start with Ruby, and then extract methods if they're going to break up long methods. There's the long method code smell, and if they're going to reduce duplication, and that's a lot of context around that too. If they're going to enhance a domain, but in this case, we weren't getting any additional enhancement of the domain. But if you are going to extract something out, see if you could reduce the scope, because then you get something that's more reusable. So I've been talking for a little while, so I think now's a good time to just take a little pause. This is Corey's cat, Zach. And, all right, I feel refreshed. How about the rest of you? All right, so the next thing I want to talk about is data pipelines. So in functional languages, rather than having objects that hold behavior and state and data that it needs to implement the behavior, what we see is data structures, immutable data structures, that we push through functions to either get information out of them or transform them in some way. And when we transform them, I'm going to use this term a lot, so let's be straight about that. We're not actually transforming those data structures. We're creating new data structures based on those that seem like a transformation. All right, so an example of a data transformation in Ruby, a very common one in Rails. This is an active support. There's this duration class. And you can build up a duration by saying beautiful things like 1 day plus 1 year. And in this example, you can even add the same kind of thing. So I've got 1 day, and then at the end, there's 2 more days. And then you can call inspect on the result of that, and it gives you this nice sentence, 1 year, 2 months, and 3 days. Now, internally, inside the duration object, that's stored as this array of arrays that you see on the bottom. And so what we need is a function that's going to get us from what we see on the bottom to that nice sentence. So in Clojure, you might do it in this way. So I've got a bunch of custom functions in here, and if you saw the keynote this morning, you saw stuff about referential transparency and being able to replace functions with their symbols. So I'm just going to blow those out so you can actually see what's going on in them. And basically, I'm not going to go into line-by-line detail here. I just want you to get the overall concept. This operator here, it's not an operator, it's a function, and really it's a macro. It takes the output of the first thing and makes it the input to the second thing. And then the output of the second thing is the input to the third thing, just like your pipelining commands on a Unix command line. And so basically what this does is it converts the array first into a series of little hash maps with 1 key and 1 value. Then it does a transformation of that into 1 hash map, merging the 2 days and 1 days into 3 days. Then it sorts it by the order of the units of measure. So years go before months. And then in sorting it, the sort by function, as it does in Ruby, if it's given a hash, it breaks it back out into a vector of vectors in Clojure, an array of arrays in Ruby. Then we transform the keys, the keywords, like years, becomes year. And that's like the only little bit of sort of transformation that we do. So we singularize years into year. And then turn that into slightly bigger sentences and then put it all into one big sentence. So this is how this is done in Active Record, or at least it was until I refactored it and submitted it, and now it does it, not Active Record, Active Support, now it does it a different way. Although it's just in the master branch, and so it's not in any release that you have unless you guys are working on Edge. So there's a few things going on here. The reason I found this code is because there's a particular anti-pattern that I was looking for, and this was an example of it. So you see how, let me see if yeah, no, that's not it. You see how we map over the array of symbols, and then on the last line of the lambda, or the block that's passed to the map method, we say if n is non-zero. So there's some conditional there. Don't even worry about what it is, but there's a conditional, and the result is going to be, if that conditional returns false, it's going to be nil. So we build up a collection of things that may or may not include some nils, and then we get rid of the nils after using compact. Now, what we really want to be doing is filtering out the things that we're not going to try to transform beforehand, right? Because right now we're doing the filtering and the transformation inside the same code block. So there's a couple of other problems. We've got special cases for nils, like I just described. We've got a special case for 0 seconds. The formatting logic is actually duplicated because if we get past, if the array is still empty after we map and compact, then we replace the whole thing with this array with 0 seconds in it. And if we were to ever decide to format that as seconds:0, we'd have to change that in both of those two places. We'd have to do it on the last line of the block and right here in the replacement of parts. This is the stuff that the drive principle is about. We're doing the same thing in two different ways, really, really, really easy to miss, right? So the drive principle says every piece of knowledge should have a single authoritative representation. It doesn't mean it should only have one representation in the system, but it should only have one source representation. So other representations come from the one authoritative source. So in this case, we're violating the drive principle. So I don't have the time to go step by step through the whole refactoring, but I'll just show you a couple of important points in it. The first thing I did was I busted the whole thing out into a series of small transformations. Now, you'll notice there's 2 maps in a row, and this is something we probably want to try to avoid for efficiency reasons. It's kind of negligible with small collections, but the nice thing about breaking it out into several steps that each do one thing is that it became very easy to see and move things around where the problems were. So for example, this line here, where, can you read that now that I highlighted it? No, probably not. So anyway, that line, we're saying, okay, if the units collection is empty, let's put this string inside, and that's where the duplicated formatting logic is, right? So I was able to just cut that line and paste it up just below the select, and change 0 seconds to just the keyword seconds, and then let this line that does the formatting do the formatting. Same solution, but now we don't have that duplication, and it was 1 line smaller. Once it was up there, I realized, well, hey, we're pulling out 0 seconds because it's not non-zero, and then we're sticking it right back in. Maybe there's a better way to do that. And so in the end result, it looks like this. So, and actually, we don't even have that temporary hash anymore that was used to just go get values from. Now we take the parts collection. Here, I'll just show you, sort of go through step by step. We take the parts collection, which is an array of arrays, converted into a hash. In Ruby, we're able to do this part in 1 step, where it converts it into the consolidated hash. Then we sort by, and it blows it back out into an array of arrays in the right order, and then we convert it into the little sentences and then put that all together into 1 sentence. Smaller series of transformations. So we get, it's much smaller, there's no temp data structure, there's no shadowing. I don't know if you noticed in the original version, but there was a parts instance variable, local variable rather, that had nothing to do with the parts method. Here, let me go back and just show you. So this parts is an internal data structure in the object. This parts is this whole new thing, so it's shadowing that. No duplication of the formatting logic, and here was the killer. So notice that here it uses chop to pull, like if we want 1 year instead of 1 year's. It was using singularize before. And the thing is, singularize is great when you don't know what you're dealing with, when you don't know what the data is, when you don't know what the strings are. In this case, we have them all right in front of us, and we could see that to singularize these, all we need to do is use chop, which is a built-in Ruby method. And it turned out that when I made that change, the performance improved by 6 times. Not like 6%, like 600% performance improvement. Now, this is one method that you may call like 20 times in your app, but little things like that can make a difference. All right, so, true story. When I made this contribution, in my mind, improving the code quality of Rails, I came up tied with Brian Helmkamp as number 82 of the all-time Rails contributors. So I'm very proud of that. So anyway, so in summary, if you don't know the enumerable methods, learn them. It's great to compose little pipelines of small transformations to do big transformations. And one nice thing that I didn't talk about, Michael Feathers did a talk a few years ago where he was talking about this idea of we should use these iterators more. And one of the comments he made was that these appear in every language. Even Java 8 has them. You could chain iterators together like this. So not yet, but soon. And you could do it in Ruby, and you could do it in all the functional languages. So this becomes not only like a common language within Ruby, but it transfers to all other languages as well. So it's a nice way to do data transformations. I don't have any more cats to show you, so I'm just going to move on to the next section. So some of you might know that I care a lot about testing. And I care a lot about how tests express the desired behavior in an application. So in the project I was working on, I was working with a guy named Jay Fields. Jay Fields used to be very well known within the Ruby community because he did a lot of great stuff and blogged a lot, and he's got a great blog, and you should check it out. He's better known now in the Clojure community because he's pretty much using Clojure exclusively for 3 or 4 years at this point. And he continues to blog, very insightful. And so Jay wrote a library called Expectations, which he had written for Ruby years ago, and but then he wrote a Clojure version. And this is what Expectations looks like. This is a test in Expectations. You say expect value function, and that function has to return that value for it to pass. And that's the whole syntax. It's really quite nice. The idea is, without test names, and with this kind of simplicity, it puts a lot more pressure on the design for it to really be readable and speak for itself. Now, the downside is, and I experienced this quite a bit, is when things don't quite work out so simply, you end up seeing a lot of comments in all the tests. And we're not storing that data, and we're not using that data in any way. So for me, this completely reinforced my love of readable test names. And this is how we do that in RSpec. And what you see is what you end up getting out. And then if you print it out with the format, how many of you use RSpec a lot? How many, keep your hand up if you use this formatter. Okay, so the rest of you should at least check it out sometime. Because for me, this is the whole reason to do all the stuff that we do inside on the input side, is to create this output that gives us this great little summary of everything that we're trying to say about the object. Makes it easy to see what's missing. Makes it easy to see where you've duplicated some tests. As with all things, there's a cost, which is that the tests are not programmatically, the names are not programmatically bound to the tests. So, just like a comment, it can get away from what's actually going on. That's your responsibility. But so anyway, moving on to a different side of testing, expectations and assertions. So in RSpec, we've had for a long time, person full name should equal John Doe. And just a little backstory on that, like years ago when the RSpec project started, part of the idea was to be able to show these to technical people. This was non-technical people. This is before there was anything like Cucumber, at least in the Ruby space. And it just kind of stuck, and people liked it, and so we kept on doing it. We recently changed I shouldn't say we, because I'm not maintaining it anymore, and I didn't do any of the work on expect. So the RSpec team recently changed to this expect syntax, not because anybody thought that it was a superior syntax to should, but because there were problems with monkey patching should and should not on every object. And it wasn't the kind of problem that most people were concerned about. People said, oh, if you monkey patch, what happens if I have a should method on my object? And I never really saw that in the whole time I worked on RSpec in any bug reports. But the problem is that there are some classes that load after RSpec has already said, OK, I'm going to patch this stuff onto object. OK, let me strip away from me everything that's not these 4 methods. And it stripped away should and should not. And so we ran into problems with those situations. You got mini-test, which looks just like test unit in this case, assert equal, expected value, and then mini-test spec, right? Person, full name, must equal. So coming up with all of these things, we spent a lot of time trying to figure out how to express these things, and there are these great discussions about which is the superior word, should or must, and why each one is valuable. And there's plenty of valid opinions about it, but we spent a lot of time on it. We're also doing a bunch of monkey patching onto things. So there's a library called wrong that takes this in a completely different direction. And it's an assertion library, and it's got one method, assert. It takes a block. That block is pure Ruby. It's got to return true or false. Well, it's got to return true for the test to pass. And if it returns false or nil, or if there's an error, wrong goes in and it actually parses the content of the block in order to figure out what failure message to give you, and it does a really good job. Now, that sort of parsing, people look at that and think that's terribly evil, but keep in mind that that only happens when there's a failure, so it never gets in the way of performance of the test run unless there's a problem that you need to go look at. In which case, a few milliseconds is not the thing you're worried about at that point. There's another library that's doing a similar thing. This is rspec given and now there's mini-test given also, by Jim Weirich. It's got this given when then syntax that we're familiar with Cucumber. And it provides failure message similarly by parsing the block content, but it uses another library to do it. So these things are kind of going in the right direction, but there's some problems with it. So in rspec given, for example, when you have a whole bunch of different contexts where the thing that's given, you need a bunch of different examples, it can get really bloated on the input side in the file. rspec with wrong, with a whole bunch of examples, we could tighten it up, right? And it's very readable, but the problem is we're violating the one expectation per example guideline. Now, I don't adhere to that religiously, but the point of it is that if the first assertion fails, then we go and we get it to pass. Well, what happens then if the second one fails? And then we get that to pass, and the third one fails. It's like this weird TDD where we never get to green, and it can be very confusing. So that's the whole reason for that principle. So we could maybe improve on that a little by putting like things together and breaking it up. So here we're handling the first names and then the last names, or maybe we could handle the nils in one case and blanks gracefully. But none of this is really getting that much better. And in this case, just spread them out, one in each example. So the problem is that we've complected two things. And I take full responsibility for this complexion. Specification, specific examples of how the code should work, and a high-level description of what we want the code to do. So a better way, I think, would be to decouple the descriptions from the expectations. Now, this doesn't exist, and this looks a lot like the slide that I showed you before, but what's happening here is it now just returns another group of examples instead of an example. And then example gives you a nameless example, except it's part of whatever it says, right? So the 6 examples in it handles nil and blanks gracefully, really that's what we want to be able to say. It handles nils and blanks gracefully. Now give me a bunch of examples of that. So this is a very nice way to handle it. And then the output could do this. So it would show you, oh, the example on line 6 failed under the concats first and last names. I hacked something together that does this, so I know it can be done, but what I did is not production ready. All right, so in summary, I still believe that test names add a lot of value. The trade-off is they require thought and maintenance. I think that's a really good trade-off. Expectation DSLs aren't giving us a whole lot of value. Now, This doesn't include mocks and stubs, test doubles. That's a completely different matter. And really, this is just a little tiny early stage thought, and I'm not sure what it'll all look like when I start using mocks and stubs in that framework. But so that still needs to be worked out. And then homework assignment for you, because I'm on to other things. Somebody please make it so you can decouple the descriptions from the examples. So in conclusion, Ruby is a DSL. We don't necessarily need more DSLs. It's already a DSL for the general domain of programming tasks, right? So when you've got something inside your method that can be expressed perfectly well by Ruby, start with Ruby. We can have readable and simple. We have to find some trade-offs sometimes, but I think it's a good thing to strive for to get both of those things. And if you're writing Ruby and you want to choose simplicity, then choose Ruby. Thank you.
Hi. So, I'm here.
OK, thanks.
So you mentioned, well, that you replaced, that example about duration inspect method.
Yeah.
And you said that, well, actually you replaced a singularize by chop. But, well, that wouldn't work with internationalization, actually.
That's a good point. There are no tests in the code that prove that point. Yeah. And it is now broken in Rails master. So we'll have to get that fixed. Okay. And we'll have to take the penalty, unfortunately. But thank you for bringing that up.
Sure, thanks.
So I liked your concept of examples. So in your draft implementation, does it execute the for blocks for every step?
Oh, yeah, it works the same way.
Yeah, so what's your thought on that? Because there's gems like Riot, I think, which only execute it once, and then you keep it immutable to optimize. So should it always be like that, or is that a case for not making that optimization?
I haven't seen that. It sounds like a great idea. So on the surface, yeah, it sounds like a great idea, and it should be able to be used in whatever this turns into.
Okay.
Yeah.
Thanks.
Please put your hands together for Dave Chelimsky.
Right. Thank you.